In this video, we're going to learn about parts of a circle, symmetry and chords, circumference of a circle, area of a circle, length of arc in the circle, and area of sector. Remember to watch until the end of the video if you would like to learn how to solve problems involving circles, and we'll start right now. Hello everyone, my name is Shirley and welcome back to my channel. If this is your first time here and you would like to improve in your math skills, start now by subscribing and clicking the bell so that you don't miss anything. Let's take a look at the parts of a circle. The first thing you need to know in this chapter is to understand the parts of a circle. So what is a center? So a center is over here, okay, and it's normally labeled as O. Next is what is a circumference. A circumference is like a perimeter of a circle. Perimeter of a circle. Okay, let's say this is point A, so it moves from here, okay, and then it goes back to here. Okay, so that is circumference. Okay, next, what is a radius? So a radius is a distance from the center to its outer rim. Okay, I'm going to draw a line. Okay, from here to here. Okay, so that is a radius. So what is a diameter? So a diameter is a chord. So a chord, okay, with the condition that it passes through the center O. Okay, and remember that diameter is 2 times the length of radius. Okay, the next part we're going to learn is about symmetry and chords. So the diameter of a circle is the axis of symmetry of the circle. For example, if the line is red color line, so it divides, this is a diameter, so it divides the circle into 2 equal parts. Okay, so therefore the red line is a symmetry of the circle. Okay, the blue line also the symmetry of the circle, and the green line also the symmetry of the circle. Okay, so let's look at the next diagram. A radius which is perpendicular, so perpendicular means 90 degrees, okay, to the chord bisects the chord. It means that if this is the blue line represents the radius and the red line represents the chord, okay, so it means that it bisects it, okay, perpendicular here is 90 degrees, okay, and bisect the chord, it means that this length is equals to this length, okay, remember that. Okay, what is a chord? So a chord is a line segment that joins both points on the circle. Okay, so this is chord. So what is a segment? So a segment is a chord of a circle that divides a circle into 2 regions. Okay, so say, okay, this region. So this is called minor segment. Okay, so this region is called minor segment. Okay, and this region is called major segment. Okay, and then what is an arc? So an arc, okay, let's say this is point A and this is point B. Okay, so an arc is a part of a circle. So in this diagram, okay, the part of a circle that joins from A to B is the arc. Okay, so next, what is a sector? So the sector, okay, so it's like a slice of a pizza. So I join, let me draw the line. Okay, so here, join to here, from the center to here, and then here. Okay, it's like a slice of pizza. And then this is the center, O, okay? And then this is the region of the sector. Okay, if you want to find the area of a sector, okay, so this is called minor sector, and this is called the major sector. Okay, so this area is bounded by 2 radius and 1 length of arc. Perpendicular bisector of 2 chords meet at the center of the circle. So the red color line, okay, is the perpendicular bisector, so it forms 90 degrees here and also 90 degrees here. Okay, so when you prolong it, okay, the perpendicular bisector, it will meet at the center O. Okay, so next, Equal chords or chords of the same length. Okay, say this length of chord is the same as this length of chord. Okay, it will produce the same length of arc. It means that from here to here, okay, this is the length of arc. Okay, it's the same as the length of arc here to here. Okay, so they are the same. Okay, so next, equal chords are equidistant from the center of the circle. So if the arc here, okay, this and this is the same, okay, and this is the same, okay, so it will form, this will be the same too. Okay, so it's equidistant from the center. Okay, and this is 90 degrees because it's perpendicular bisector. To find the circumference of a circle, we need to memorize this formula. So circumference is equals to pi d or 2 pi r. Okay, let's look at this example. Given the circumference of a circle is 24.5, calculate the diameter and also the radius. So to find the diameter, I'm going to use the first formula, which is c equals to pi d. Okay, so c equals to pi d, and pi is a constant and the value is 22 over 7 or 3.142. But for this, okay, I use 22 over 7, okay, because it's not stated that we have to use which one, whether it's 22 over 7 or 3.142. So circumference is 24.5, I'm going to write here, okay, and pi, I'm going to use 22 over 7, okay, times with the diameter, which is unknown. Okay, so to find diameter, okay, we have to move the fraction over to the left-hand side, okay, so it becomes 7 over 22, okay, so to find d, okay, we have to use the calculator, yeah, 24.5 times with 7 over 22, so we get 7.8 cm. Okay, so 7.8 cm. Okay, now let's solve B. To find the radius, okay, we know that the radius is half of a diameter. Okay, so just now we already found 7.8 as a diameter, so I'm going to substitute into here, so times with 7.8. Okay, so let's calculate 7.8 divided by 2, so we get 3.9 cm. So it's equals to 3.9 cm. So that's the answer. For area of a circle, we have to memorize this formula. So area equals to pi r squared. Okay, let's look at this example. Calculate the area of a circle if the circumference is 15.4 cm. Give your answer correct to 2 decimal places and you have to use pi equals to 22 over 7. So for this, given c equals to 15.4, which means that we have to use the circumference formula first. Okay, so circumference is equals to 2 pi r. Okay, this is for us to find r. Then after we have found r, we apply it into the area of circle formula. Okay, so circumference is 15.4 equals to 2 times 22 over 7, okay, times with the r. Okay, so the r is unknown. So to find r, okay, we move the 2 and 22 over 7 to the left hand side. So we get 15.4, okay, times with 1 over 2 and times with 7 over 22, okay, to find r. Okay, let's work this out. Okay, 15.4 then divided by 2 times 7 divided by 22, so we get 2.45, okay, so 2.45 cm. Okay, after that, okay, we have to find the area of a circle. So the formula for area of a circle is pi r squared. Okay, so I'm going to apply the answer that we gotten just now, which is 2.45, okay, into here. Okay, so we get, okay, 22 over 7 times with 2.45 and you square it. Okay, so let's work this out. 22 over 7 times 2.45 times 2.45. Okay, so we get 12.87. 12.87, okay, cm square is the unit for area and it's in 2 decimal places. So that is the answer. To find the length of arc of a circle, we need to use this formula. So length of arc is equals to theta over 360 times with 2 pi r. Okay, so 2 pi r is actually the circumference of a circle that we learned just now. Okay, So let's look at this example, yeah? The diagram shows a right angle triangle, PRT. R is the center of the quadrant. Given RS is equals to 14 cm. So I'm going to label RS, okay, as 14 over here. Okay, which means this is also 14, okay, because radius is the same. And SD is equals to 10 cm, means this is 10, okay, and PQ is equals to 4 cm, and this is 4 cm. So calculate the perimeter of the shaded area in cm, okay, which means that we have to add up. Okay, so this is given, and this is also given. Okay, so we need to find the length of PT. So in order to find the length of PT, okay, we use Pythagoras theorem since it's a right angle triangle. So we need to know what is this length, okay? So 4 plus 14 is 18, okay? And also this length, okay? So 14 plus 10 is 24, okay? So now we can calculate what is the length of PT by using Pythagoras theorem. So PT square is equals to 18 square plus with 24 square. Okay? So therefore PT is equals to, so 18 square is 324. Okay? Plus with 24 square is 576. And then we square root the whole thing. Okay? Let's calculate this. 324 plus 576 and square root it, then you will get 30 cm. Okay, so equals to 30 cm. Then I have to label here 30. Okay, so now there's one more part which we need to find, which is the length of arc of QS. So this is a quadrant. Okay, and quadrant is 90 over 360, or you can use 1 over 4. Okay, it's up to you. So to find the length of arc, I'm going to write here, length of arc, okay, of QS, okay, is equals to, so I'm going to use this formula, okay, so the angle is 90 degrees over 360, then times with 2 pi r, so 2 times with, because they say use 22 over 7 as a pi, so 22 over 7, okay, times with radius, so radius is 14 in the diagram, okay, so let's calculate this. So 90 over 360 times 2 times 22 over 7 times with 14, so we get 22 cm, okay, so this 22 cm. So therefore, this is 22. Okay, so now we have all the 4 sides, we can find the perimeter. Okay, so the perimeter of the shaded area. Okay, is equals to, I'm going to add up all the 4 sides together. So 4 plus 30 plus 10 plus 22, okay? So let's calculate. So 4 plus 30 plus 10 plus 22 is equals to 66 cm. So 66 cm is the answer. To find the area of a sector, we have to memorize this formula. So theta over 360 times with pi r squared. Let's look at this example. So Kevin wants to build a dartboard. The dartboard consists of 2 circles centered at O and 3 shaded regions as in the diagram. The diameters BOD and AOC are perpendicular to each other. Given OE is equals to ED equals to 10 cm. So which means that this is 10, this is 10. Okay? Calculate the area of the shaded regions in cm squared. So as we know that there is one big circle and one small circle. So the big circle, the radius is 20 cm. And the smaller circle, the radius is 10 cm. Okay, so I'm going to find the shaded region, I'm going to move this small little quadrant to the bottom to make up one full quadrant. Okay, one full quadrant here. Here. Okay, so here will be no more already lah. Okay, so I'm going to find this. So to find this area, I'm going to use a quarter because it's 90 over 360. A quadrant is always a quarter. Okay, so times with, because it's area, so it's pi r squared. So it's 1 over 4 times with 22 over 7, which is the pi value, times with r. So r is, for the big quadrant, is 20 squared. Okay, so let's calculate this. So 1 over 4 times 22 over 7 times with 20 squared. So we get a fraction which is 2,200 over 7. Okay, so I'm going to write here 2,200 over 7 cm square. So we just leave the answer as in fraction first because it's still not final answer yet. Okay, so next I'm going to find what is this area. Okay, so for this I'm going to use the bigger quadrant minus the smaller quadrant. Okay, so the bigger quadrant, okay, is 1/4, okay, times with pi, which is 22 over 7, times with the bigger radius, which is 20 square. Okay, so minus with the smaller quadrant, 1/4 times 22 over 7 times with 10 square. Okay, so as we have found just now, this is the area of the bigger quadrant. I can just apply it to here. Okay, and then we just find what is the next. The answer for the bracket, 1/4 times 22 over 7 times with 100. Okay, 10 square is 100. So this is 550 over 7. Okay, so 550 over 7. Okay, let's work this out. 2,200 over 7 minus 550 over 7. Then we'll get a fraction, okay, which is 1,650 over 7 cm square. Okay, so now we can answer the question. Okay, calculate the area of the shaded region. So therefore, the area, okay, of the shaded region, okay, is equals to, okay, I'm going to add this 2,200 over 7 plus with this one, 1,650 over 7, and then we will get, okay, let's work this out. So 2,200 plus 1,650, then whole thing divided by 7, so we get 550. Okay, so 550 cm square, and this is the final answer. Well, that's all for now. Stay tuned to my next video, which is past year questions involving circles, coming up soon. Bye!